try a different example. A couple of things are going to be different here. One is that we're adding a base instead of adding an acid. And instead of saying, okay, we're going to add this thing and see how the pH changes, we're saying, okay, we want this desired pH. How much of the base do we need to add in order to get that to our desired pH? Now, in the previous examples, we're considering volume because, as we'll see in this example, you might need to add a lot of the acid or a base in order to change the pH to where you want it. So instead of just making a solution to the final volume that you want and then trying to adjust the pH, what we do in the lab is we typically make things, we dissolve the amount of the acid or of the base or of some combination of the two in less than the desired full volume. Then we adjust the pH and then we raise that volume to the final volume. And this way we don't need to worry about how much volume we added when we were adding that acid or base because we're just dealing in terms of, we're thinking in terms of the final concentrations, and we'll just adjust the volume at the end to get to that final volume that we want. But by starting with a lower volume, well, now we're not going to overshoot things. So in this equation, in this example, what we're saying is how much 1 molar sodium hydroxide, so that's a strong base, remember, when you dissolve it, it's going to dissociate. So that'll be basically just adding OH minus, and that could react with our acetic acid to give us acetate. So we're saying, okay, how much of that would we need to add to bring 150 millimolar acetic acid acetate solution to a pH of 6 with a final volume of 100 milliliters? So again, you calculated in lab and stuff, we'll calculate how you, we'll do example calculations to figure out how much you need to weigh out of your acetic acid or of acetic acid and acetate, different ways that you can do things. But we want to say in this case, okay, we have a solution of acetic acid and acetate that we dissolved. So we dissolved some acetic acid and some of it dissociated, some of it didn't. We end up with some original equilibrium. That was one of those like type 1 problems where basically we just dissolve an acid. And so we're saying that, okay, we dissolve it. So we have 150 millimolar, we want our final solution. We have 150 millimolar worth of some combination of acetic acid and acetate. So that's going to be where we have our H plus our A minus is going to be equal to 0.15. And now we want to bring it to a pH of 6. So we knew before that if we had like 100 milliliters of 150 millimolar solution of acetic acid and acetate, we are going to end up with a pH of about like 2.8, which is way lower than we actually want. So we're going to think we're going to need to add a lot of base, right? But how much? So to do this, we're going to take a strategy. We're going to determine the original concentration of our acetate, and this is just by using the definition of the pKa and doing one of those like first types of problems that we did earlier in the video. Then we're going to determine the final concentration of acetate. And here we're talking in terms of concentrations because we're talking about, remember, we're adjusting our volume at the end, so we don't need to worry about a changing volume along the way. But we do want to know what's the final concentration of acetate that we need, and we can do this using our Henderson-Hasselbalch equation. Then we're going to go ahead and we're going to calculate the difference in the concentrations of acetate between our final that we got from the Henderson-Hasselbalch and the initial that we got just from the pKa. Now, then what we're going to do is we're going to take that difference in concentration and convert it to moles, because that's the moles that you need to basically react. And so that's in order to get that many moles of acetate, once you've already like kind of let it reach equilibrium, you want to see, okay, well, how much now do I need to add from an external source in order to get it where I want? That's going to be, you find the number of moles, and then that's the number of moles of NaOH you need. And then you're going to take the NaOH, and then you're going to calculate how many mils you need by dividing that by the molarity. So let's go ahead and let's take these one by one. So let's start with our original concentration of acetate. We found out before that this was 0.0150 molar. And again, go back and previous slides, we went over that, or you could always just go back and use it using your pKa equation. Now what we're going to do is we're going to find the final concentration of acetate. And to do this, we're going to use Henderson-Hasselbalch because remember, we're adjusting the pH. So our pH, we want to get it to a pH of 6 equals the pKa 4.8 plus log of our acetate over our acetic acid. Okay, so now we're going to have 1.2 equals log of our acetate over our acetic acid. We're not adding acetate, we're adding NaOH. So if we think about what our equation is actually, what's actually going to be going on is we're going to be having this solution where we have our acetic acid, and then it's going to be reacting with this OH minus that we put in. And this is going to give us then our acetate. And so this is the situation that we're going to be dealing with. And so we're not going to be changing the we're not going to be changing the total concentration of our acetic acid plus acetate. So if we think about our acetate concentration as X, well, our acetic acid concentration has to be 0.15 minus X. And so now if we're looking for A minus over HA, we can think about that as X divided by 1.15 minus X. And so now we can go ahead and we can plug that in. 1.2 equals log of our X divided by 0.15 minus X. And we end up with a number that's about 0.141 molar. Okay. An alternative way that we could have done this was similarly to how before, we find the fraction of this acetate and then multiply that by the total concentration. So in this case, basically we have our 10 to the 1.2, which we got from our pH of 6 minus the pKa of 4.8 would give us 1.2. We take 10 to the 1.2 and we get 15.8. Remember to find the fraction, we then have to divide that by that number plus 1, taking into account that that's per 1 part of our conjugate acid. And this is going to give us a value of 0.94, which then can multiply by the concentration to get 0.14 molar. So now we want to find the change in acetate though. So now we're on number 3. So let's just clean this up a little. Okay, we want to find the change. So to find the change, we have the final. Remember, we just calculated the final 0.141 minus the initial 0.0150 is going to equal a change in the concentration of 0.126 molar. So that's our change in molarity. And we need to figure out, okay, well, how many moles is that? Because we want the final volume of 100 milliliters, that's telling us that we have 0.126 moles per liter times 0.1 liter is going to be equal to 0.0126 moles. Okay, so let's think about what this is telling us. This is telling us that the amount of OH that we need is 0.0126 moles of NaOH in order to change the pH enough that we're going to get it to the desired pH. So we need that many moles worth of the acetic acid to react after it's already reached its equilibrium. And so this is the amount that we need, this 0.0126 moles. But now we don't have moles on our bottle of NaOH, we have the concentration. And we have a concentration of 1 molar, which makes things easy because then what we have to do is 0.0126 moles times, we just have to do, we have 1 mole per liter. So we're dividing by the concentration, and we're going to get 0.0126 liters, which is going to be, we move our decimal point 123. So that's going to be about 12.6 mils. And so you can see that if we prepared our solution to have, if we dissolved everything in 100 milliliters and then we needed to go adjust the pH and we had to add 12.6 milliliters of our NaOH, well, that wouldn't work out so well. So that is why we do the volume, we figure out the do the pHing stuff at a lower volume, and then we adjust it to the final volume. And you can always calculate ahead of time about how much you need to add. Another thing that you could do if you want to start closer to the desired pH is, instead of just dissolving the acid and letting it get where it wanted, we could have started by adding some of the acetate. So you can add like sodium acetate or something like this. And that way you're kind of tipping the scale from the beginning, rather than adding the OH and having it react with the acetic acid to make the acetate. So those are